Hello everybody, in this video we're going to be tackling compound inequalities. So in the last video we worked at solving and graphing a linear inequality. We're basically going to be doing the same thing here but with compound inequalities, which are just two or more inequalities connected by the words and or or. And or or. Alright, so in this first video we're going to tackle the and part. So this is only true if both inequalities are true. So the solution is an overlapping region. So what does that mean? What if we have something that says x is less than 5 and x is greater than or equal to 0? So if I just graphed x is less than 5, it would be an open circle at 5 shading to the left because x is less than 5. If I have something like x is greater than or equal to 0, if I've got this second inequality here, it would be a closed circle at 0 because I have equality. And since x is greater than or equal to 0, I'm going to shade to the right. I'm actually going to make this a little bit longer. So if you have a situation like x is less than 5 and x is less than or equal to 0, sometimes you may see it written like this. But if you basically have this inequality, it's going to be these two inequalities sandwiched together, and I'm only going to highlight this shaded region. So I start at 0, and 5 is the max, and I'm going to shade this region in between them. All right, because that's if I graph those two inequalities together, that would be the overlapping region. You can see it right here. Okay, so when we're graphing a compound inequality with and, we're looking at that overlapping region. Okay, so let's work through these. In example 1, we're given that 12 is greater than 4x and negative 5x plus 5 is less than or equal to 25. So we need to solve each of these. We got to get the x by itself. So in this first one, 12 is greater than 4x. Divide both sides by 4. I'll get 3 is greater than x. All right, I'm not going to worry about graphing for right now. I mean, the most I can do is put an open circle at 3. That's all. That's the best. That's the only thing I should do right now. All right, and then we get negative 5x plus 5 is less than or equal to 25. Excuse me, I'm going to subtract 5 from both sides, so we get negative 5x less than or equal to 20. Divide by negative 5, so I get x is greater than or equal to negative 4. We need to remember to flip the sign because we divided by negative 5. So x is greater than or equal to negative 4. So I can put a closed circle at negative 4. Okay, so if I rearrange these so that the x is first, I get x is less than 3. So that means x is less than 3, that's shading this way. And x is greater than or equal to negative 4, which is shading this way. So the overlap region is this region, oops, that's bad. This region in between them, just connecting those two circles. Okay, so you may also see this written as x is less than 3 and x is greater than or equal to negative 4. All right, this is the minimum value. This is the max. So you may see your final answers written like that when I'm dealing with the word and, connecting my two inequalities. Okay, just like we see it in number 2. We don't see the word and here, but we are seeing that negative 19 is less than or equal to 2 plus 7x, and 2 plus 7x is less than 44. So what I'm going to do is I'm going to split this up. I'm going to say, okay, negative 19 less than or equal to 2 plus 7x. That's one of my inequalities. And the other inequality is 2 plus 7x is less than 44. So I'm basically splitting this up into the first inequality and the second inequality. This just makes it a little bit easier to solve, just by splitting it up, not trying to do everything all at once. So this first one, subtract 2 from both sides, negative 21, less than or equal to 7x. So I get negative 3, less than or equal to x. All right, or you could say x is greater than or equal to negative 3. Either way. All right, so I've got a solid dot at negative 3. X is greater than or equal to, so that's shading off to the right. All right, now let's look at the second inequality. 2 plus 7x is less than 44. Subtract 2 from both sides. I'll get 7x is less than 42. Divide by 7, I'll get x is less than 6. So it's an open circle at 6, shading off to the left. All right, and then if I were to sandwich this all together, I would get x is less than 6 and x is greater than or equal to negative 3. So x is sandwiched in between negative 3 inclusively. What that inclusively means is I include negative 3 because I have less than or equal to. So x is in between negative 3 inclusively all the way up to 6. So then I just connect and I shade in between those two. All right. So you'll see that to solve a compound inequality with and, you should split them up, solve both of them at the same time, or solve both of them, and then you could sandwich them together like these boxed answers have, and then you can graph it. And the graphing, the and, they're going to be facing towards each other. That shading is going to face towards each other. All right, so that's and inequality. All right, I will show you, just to kind of extend this a second, and looking at this second one. You could solve this all at the same time. I encourage you to split it up, but if you're super strong in your solving skills, what we can do is say subtract 2. So I'm going to subtract 2 from everything. So then we get negative 21 less than or equal to 7x less than 42. And then I can divide everything by 7. And I'll get negative 3 less than or equal to x less than 6. So you'll see these two answers match up. All right, so it may seem like a little less work there, okay, but it's more easy to make a mistake if you keep it all in one. So I would encourage you, just as we're practicing this and as it's new, split it up. That way you recognize that it's two different inequalities. All right, and then practice sandwiching it back together for this final answer, negative 3 less than or equal to x less than 6. Okay, so after a little bit of practice, maybe you'll be able to do it all in one. All right, but for now, split it up and solve each inequality separately before smushing them back together. All right, in the next video, we'll talk about what do inequalities that are combined by the word or look like. All right, stay tuned for that video.